We're going to continue to use some of the things that we used right before fall break there with the solving with square roots. We're going to be using that some today as well as we learn to solve quadratics by completing the square is the method that we're going to use here. So it is going to involve solving by square roots. So I thought we probably should review. Some of you may not have done much of this over the break, depending on if you got done with that work or not. Either way, it's a good review. All right. So let's review the rules for solving by square roots. What has to be by itself before you can take a square root? The squared part, right? So with most of the ones that we had done before fall break, it was just x squared. So when you look at example number 1, we've got x squared is equal to 49, and x squared is by itself. So the next step is to do what? Take the square root of both sides. And it gives us x. And then we know that the square root of 49 is 7. So plus or minus 7. So we have two answers, positive 7 and negative 7. Every quadratic should have two answers, even if it's the same answer twice. Number 2 is a little bit different. So this takes us to the next step, kind of headed in that direction of what we're trying to do today. And we look at that problem, and it's very similar to example 1. The only difference is if you got this parentheses here with x minus 2 in it, but that is squared. So for this one, the squared part is not just x squared, it's x minus 2 squared. So that squared part is by itself, and you got a number on the other side. To get rid of this squared here on that side, what's the easiest way to undo squaring something? Take the square root. So if I take the square root of that side, what do I have to do to the other side? Take the square root, right? Same thing has to happen on both sides of an equation. So when I do that, the left side is going to turn into x minus 2, and the right side is positive and negative 7, two different numbers. But x is not by itself yet. On example 1, x was already by itself. We knew the answer is positive 7 and negative 7. But this one, you got x minus 2 there. It's not plain old x. So we need to set up two equations. X minus 2 equals positive 7. X minus 2 is equal to negative 7. And then solve those. Add 2. X can be positive 9. Or negative 5. Those are our two solutions for that problem. So here we had the squared part was the parentheses thing. That's what we're going to kind of see as we go through the stuff today. We're going to be manipulating some problems to turn them into problems like number 2 so that we can do that. Let's look at number 3 here. Let's say we had x plus 3 squared minus 2 is equal to 16. A little bit different looking, but the idea here is to kind of learn what you need to have it looking like so you can solve it by square root. So we want to get the squared part by itself. So what needs to move? The 2. So how do we move that 2? Add it to both sides. That cancels that out, and that gets us the x minus 3 or plus 3, excuse me, squared is equal to 18. And the squared part is now by itself, right? So I can take the square root of both sides to get rid of the parentheses because I need to get x out of there. So if I take the square root of both sides, it gets me x plus 3. And then, does 18 have a good square root? No, so we got to simplify that square root. So how do we simplify square root of 18? You can do the tree thing. That'd be 6 times 3. 2 times 3, so there's a pair of 3's. So plus or minus 3 square root of 2. If you use 9 and 2, you get the same thing comes out there. Now, this one actually looks a little easier because can you add 3 to 3 radical 2 and combine those? No, they're not like terms. This has got a radical on it, so you can't put them together. So we can get x by itself by just doing one step here. Instead of having to split up and do 2 problems, we can just subtract 3, get negative 3 plus or minus 3 radical 2. That's two separate answers. That's -3 plus 3 square root of 2 and -3 minus 3 square root of 2. If we needed to get the decimal approximations for it, later on we'll do that when we get into some graphing and some word problem type situations. We could do that. We could just work that out with a calculator. But this is the exact solutions, and that's the ones that we want for this stuff. Okay. Do another one similar to that. Example 4. Let's do x plus 2 squared plus 4 is equal to -8. What would it be our first step for this one? Subtract 4. That would get the squared part by itself. So x plus 2 squared is equal to -12. And then we can do what? Take the square roots, because we want to get rid of that squared that's on those parentheses. Don't forget, on the number side, you got to have a plus or minus. So on the left side, that's the easy side. That's x plus 2. On the right-hand side, we got a negative number underneath the square root. So what do we know comes out for sure? An I, and then maybe anything else. So we think about breaking down the 12. 6 and 2, 3 and 2. There's a pair of 2's. So that'd be plus or minus 2i square root of 3. So we got complex solutions for this one. So we got to do one more step to get x by itself. We're going to subtract 2 from both sides. X is equal to -2 plus or minus 2i square root of 3. So we got two answers there. -2 plus 2i radical 3 and -2 minus 2i radical 3. So at this step, the simplifying of the square root, that's all the stuff that we did before fall break. We got this extra step here is kind of where we're at now. Okay. But overall, not too much more to it than what we were doing before fall break. Okay. So let's look at, well, what if the problem doesn't even look like that to begin with? What if it's needs to be put into that form so that we can use square roots to solve it? And that's where completing the square comes in. Okay, so we're gonna write the process out to complete the square. What completing the square does is it allows you to take a quadratic that's not in the form of the ones that we were just working, like numbers 2, 3, and 4. If it's not in that form, completing the square, we can put it into that form so it's a quick and easy solve. And that's can help us sometimes. All right. So the first thing that you want to do is rewrite. So if you've got a problem, ax squared plus bx plus c, maybe it's equal to 0, maybe it's equal to some other number. It really doesn't have to be equal to 0. It can be equal to anything. But this is a quadratic that's just normal, like we would use factoring or something to solve. Okay, but we want to try to use completing the square. So we're going to rewrite as ax squared plus bx equals, and we'll say c there, but it doesn't necessarily have, it's not always going to be the same number if there's something else over there. So we're going to rewrite it to where the x squared and the x are the only thing on the left side. Yeah, no, go ahead. I'll just pause. You got on your jammies. They won't take your picture. All right, back to the world of mathematics. All right, so we're going to rewrite that thing to where the x squared and the x are on the same side. And then there's a number on the other side. Okay. After we've done that, the next step, it's not a long thing, it's like 4 steps, so it's not hard. We're going to divide by a. Okay. The reason we're doing that is because it makes the factoring super easy. Because if you divide by the number that's in front of x squared, then, when you think about the factoring, it gets a lot easier to do because you can take that shortcut to do that. So that would put a 1 in front of x squared if we do that. All right. Next thing we do is this is where we're actually going to complete the square. And when we see an example of this, it starts making a lot more sense. So we're going to complete the square. We're going to take half of the number that's in front of x. We're going to square that value and add that to each side. Fourth step, I call this the quick factor. The reason you'll see as we go through this why I call it quick factor, because you're making it factor a certain way. The complete the square step makes the factoring where you don't even have to think about it. It's automatically this every single time. So quick factor the quadratic, solve by square roots. All right. So get x and x squared on the same side, everything else to the other side. Divide by the number in front of x squared, a, and then we're going to do the complete the square part. Okay. This makes it a quick factor, easy factoring on the quadratic, and then solving by square roots. So it can speed up the process of solving for that. All right. So let's look at an example. This is example number 5. We'll start with x squared minus 18x minus 5 is equal to 51. Start with something like that. Okay. So this one is, if we wanted to try to do this by factoring, we could have to move the 51, get it equal to 0, then do the x method, that sort of stuff. We want to try to use complete the square to do this. So the first thing that we need to do is move the plain number over to the other side of the equal sign and get x squared and plain x on the same side by themselves. So I'm going to add 5. Right? So that's going to give me x squared minus 18x. I'm going to leave a little space and then have my 56 over there. Okay? All right. Now, the next thing I want to do is take half of the number. What's in front of x squared here? 1. If I divide everybody by 1, does it change anything? No. So that kind of, this one's got a little bit of a shortcut in it. We don't have to do that step. So I can step where I'm completing the square. To complete the square, I'm going to take half of negative 18. What's half of negative 18? Negative 9. And I'm going to take negative 9 and I'm going to square it and add it to both sides. What do we know about negative 9 squared? It's 81, isn't it? So I really have x squared minus 18x plus 81. And then on the right-hand side, I can go ahead and add 56 and 81 together. 56 plus 81. 137. Okay? On the left-hand side, here's the beautiful thing that happens. Because we completed the square on this, it will factor. If I did the x method on this, what are two numbers that multiply to be 81 and add to be negative 18? Negative 9 and negative 9. So the factors would be x minus 9 and x minus 9. The same factor twice. What's another way of writing that? Now that in red looks like the problems we were doing on numbers 2, 3, and 4, right? we can solve that by square roots. Okay? The shortcut to the factoring, the quick factor part is, what's negative 9? Where did that come from? Half of negative 18, right? It's always going to factor that way. If half of b is negative 9, it's going to be x minus 9. If half of b was 17, it'd be x plus 17. That the quick factor is it's always half of b. Half of the number in front of x. So now we just take the square root of both sides. X minus 9 plus or minus the square root of 137. I don't know much about 137. Adds to be 11, so it's not divisible by 3 or 6. Maybe it's divisible by 13, maybe? I don't know. Oh. 37 divided by 11. Doesn't look like it's divisible by anything. It looks like it's a prime number, which is nice. That means there's nothing I can do to break it down. And now all I got to do is get x by itself. I add 9. 9 plus or minus the square root of 137. There's my two answers to that problem. So this one, the square root didn't work out for us. It wasn't a nice number. That's okay. But completing the square, that's the process we're trying to learn today. Let's look at number 6. 2x squared minus 16x equals negative 30. For some reason it stops casting time to time. Get that going real quick. Just a second. There we go. 2x squared minus 16x is equal to negative 30. So we've got the plain number over there on the other side of the equal sign already, because they're kind of ahead of us a little bit here when they set this problem up. But what's the next step? Divide by the 2. The number that's in front of the x squared, we need to divide by it, get rid of it. So I'm going to divide everybody by 2. It's going to be x squared minus 8x. I'm going to leave a little space because I know I'm going to complete the square next. So I have x squared minus 8x is equal to negative 15. And now I want to complete the square because I've got it set up for doing that. So what's half of the number in front of x? The number in front of x. So it'd be negative 4, right? So I'm adding negative 4 squared, which negative 4 squared is 16. So I just went ahead. On the number side, I'm just going to go ahead and work that number out. And negative 15 plus 16 is 1. And then what does the left side factor as? X minus 4. Whatever half of that middle number is, that's what's going to be in that factor every time. When you complete the square, that's always what's there. Then we solve by square roots. Square root of the left side, square root of the right side. Positive and negative 1 is the square root of 1. So this one I can actually work out, so I need to split it up into positive 1. X minus 4 is equal to negative 1, and solve. X equals 5, and x equals 3. So because it was a nice number, go ahead and work it out. If the square root works out to be a nice number, go ahead and split it apart and find those two answers. If it's still got a radical in it, or if it's got an I on it, you don't have to do that. You have one little statement there. Okay. Number 7. 4x squared minus 8x plus 6 is equal to 3. Right. What do we do first? Move the 6. Subtract the 6. Good job. 4x squared minus 8x equal to negative 3. Now what? Divide everybody by 4. We're lucky on the left side it works out nice and even there, so we get x squared minus 2x. On the right side, it doesn't go into it evenly, so leave it as a reduced fraction. Reduce it as far as it'll go, but just leave it as a fraction. Negative 3/4. Am I ready to complete the square on this? Is it set up for that? Okay, so what do we do to make it complete the square? Half of negative 2, which is negative 1, and we square that and add it to both sides. When you square negative 1, what do you get back? 1. So notice how I'm writing it on the left side. I'm just putting what half of b is in the parentheses there, because I know when I factor this side, what's it going to be? X minus 1, right? In the factor. And then on the other side, we got negative 3/4 plus 1. So if you got $1 and you take away 75 cents, you got a quarter left, right? Now what? Take the square root of both sides, right? And we've done square roots of fractions. Square root of 1 is 1. Square root of 4 is 2, right? So we got x minus 1 is equal to positive and negative 1/2. So when can I combine a 1 and a 1/2? Yeah, they're just regular numbers, aren't they? They don't have a square root in it. They don't have an I in it. So I can split this one apart and work it out because they're just regular numbers. Add 1. 1.5 would be 3/2. Add 1. And 1/2 or taken away from 1 is 1/2. Get our answers there. Fractions, fun thing. Everybody loves them. But that was not too bad with the fractions in it because your factoring didn't have to deal with the fractions as much. So again, it's a step-by-step process. It's you learn that pattern, that process, and what you need to go through. This is not hard. Let's look at another one. Say we had 3x squared plus 10x plus 6 is equal to negative 2. Oh, internet's. We got much left. We'll just hang on with us for just a little bit. And it didn't go. Yeah, let's that. Just a second, guys. Okay, so what do we do first on this one? Subtract 6. So we get 3x squared plus 10x is equal to negative 8. Now what? Divide by 3. But it doesn't go evenly into everything. Oh well. Still going to follow the process. Now, what's half of 10 over 3? 5 over 3? Okay, how do you do that? Divide with the, what if the numerator is not divisible by 2? What if it were like 7 over 3? Well, it's going here. That's pretty soon, yeah. I don't know. Quit and go home. Back again. So really, when you're taking half of a fraction, you multiply it by half. If it does reduce, great. If it doesn't, basically it's 1 times the top, 2 times the bottom, and that does give us 5 over 3. So we're going to add 5 over 3 squared to both sides, right? Because that's what the process for completing the square is. Now, when I square 5 over 3, that's going to be 29 or 25 over 9. Right? What's the factoring on the left side? Good. Shouldn't be a whole lot of thinking involved in that. It's always going to be x and then whatever half of b was. Since it was a positive 5 over 3, it's a plus 5 over 3. Always going to be that short and that quick. So that's why I call it a quick factor. You shouldn't have to think about it. Okay. Now we need to work out that side. Negative 8 over 3 plus 25 over 9 would be 1 over 9, right? Well, common denominator would be 9, so negative 8 times 3 would be negative 24. So that makes sense. Now what? Take square roots both sides. That works out kind of nice. The square root of 1 is 1. The square root of 9 is 3. So we got plus or minus 1/3 over there. Can I work that out? Yeah, because they're both just fractions. So x plus 5 over 3 equals positive 1/3. X plus 5 over 3 equals negative 1/3. Subtract. Negative 4/3. Negative 6/3, which is negative 2. Works out nice on that. But, the fractions in there, they make it a little tougher. You got to think a little bit harder, but it's the same process. And the factoring part makes it real easy there. Because you're doing that always going to be x and whatever half of b was. Good. 2 more, and we'll be done. Number 9, x squared plus 14x minus 21 equals negative 5 minus 2x. This one looks a little weird. Nowhere near the right form for us to get started on it. So what do we got to do first? Add 2x to get the x's together. Add 2x to this side and that side. What else could I do? Move the 21 by addition. I'm just going to do all of that in one step there. That shouldn't be too daunting for you to do. So we get x squared plus 16x is equal to 16. Now what? Half of the b. So half of 16 is 8. So we're going to add 8 squared, which we know 8 squared is 64, right? So this will factor as x plus 8 squared And then the right-hand side is what number? 80. You guys are getting quicker at it. Take the square roots. And does 80 have a nice square root? No, so I need to break it down. One pair of twos, two pairs of twos. So that's going to be plus or minus 4 square root of 5. And can I combine that if I move the 8? No, they're not like terms. So I don't have to split this one into two separate equations. I can just move the 8 by subtraction. Get x equals -8 plus or minus 4 square root of 5. And leave your answer like that. Remember, the only time you need to split it into two and get two separate answers is if they're just regular numbers. How of that? We had a square root left in there, so we know we can write our answer that way. Let's look at one more problem. Number 10. 4x squared plus 76 is equal to 16x. Uh-oh. Okay, we can do that. We take away 4x squared. It'll give me 76 equals -4x squared plus 16x. Okay, I got to divide by the number that's in front of x squared, which was -4. Everybody gets divided by that. So that's x squared plus, or excuse me, minus 4x. And then -4 goes into 76, -19 times. Good. -2 squared. -2 squared would be 4, right? So it's going to be -15. And then what's the factoring on the left, on the right-hand side? X minus 2 squared. Good job. Now what? Take the square roots, plus or minus on the number side. So x minus 2, and then what's the square root of -15? What? Got to take the I out because it's a negative, but there are no pairs. 3 and 5 is what it splits into, but that doesn't give us any partners there. So it's going to be plus or minus I square root of 15. And then what do we do to get x by itself? Just plus 2. And so we have 2 plus or minus I square root of 15 is equal to x. 2 solutions for that. So even with the complex numbers mixed in there, it really doesn't get too difficult. Actually, I think it's easier when it doesn't have a nice square root to it. It's quicker. You know, you don't have to do 2 different problems out of that. So pretty easy thing here to get us kind of easing back into this quarter after extended break. So practice for this, there's 12 problems on here. You should probably be able to get this done today. Or if you still lack some work on homeworks 3, 4, and 5, you can be working on that as well. All of this will be due Wednesday when you come back. So be preparing for that, and then we'll keep moving forward.